Program 15-minute hold.
And we're in our hold at T-minus 4 minutes. It's a planned 15-minute hold. This is Atlas Launch Control. Launch minus 17 minutes and counting. In about 4 minutes, the terminal count readiness poll will be conducted. One of several polls that will be held during this hold in order to assure that everyone is ready for launch. You're looking at the Atlas rocket at Space Launch Complex 41. The rocket is 189 feet tall, about 19 stories, and weighs more than 700,000 pounds fully fueled. And with the combination of the RD-180 engine and the strap-on solid rocket booster, the Atlas will lift off, courtesy of 1.2 million pounds of thrust at 7:05 p.m. Eastern Time. This is Atlas Launch Control at T-minus 4 minutes and holding. And if you're just joining us, we're just under 15 minutes away from launch as managers assess the health of the Atlas V rocket and spacecraft during this planned 15-minute hold. No technical issues of note are being worked. Weather is 90% go, and crystal clear skies seem to ensure that we will not have an issue with the weather today. During this hold, NASA Mission Manager Rex Engelhardt, OSIRIS-REx Spacecraft Mission Director Mike Donnelly, NASA Launch Manager Tim Dunn, United Launch Alliance Launch Director Bill Cullen, and United Launch Alliance Launch Conductor Scott Barney will be pulling their teams of engineers across the country, culminating in the decision to release the hold at 7:01 p.m. for an on-time launch at 7:05 p.m. And if any issues should crop up, the hold could be extended. The launch window this evening lasts an hour and 55 minutes, so we could launch as late as 9 p.m. But again, everything is proceeding normally at this time, and we expect an on-time liftoff at 7:05 p.m. Eastern. This is NASA's first mission to take a sample from an asteroid and return it to Earth. The OSIRIS-REx mission will help scientists investigate how planets formed and how life began, as well as improve our understanding of asteroids that could maybe one day impact Earth. OSIRIS-REx is traveling to the near-Earth asteroid Bennu, where it will bring a sample back to Earth for study as part of NASA's quest to study our solar system and beyond. And we're standing by for the first of our launch poles. NASA Launch Manager Tim Dunn conducting a poll, and his team is go for launch. We'll continue to listen to the various audio circuits where managers will be conducting their polls, culminating in a final go-no-go poll as we approach the end of our hold at about 5 minutes away from launch. This is Atlas Launch Control. This is Atlas Launch Control, T-minus 10 minutes, 27 seconds, and counting. In a little bit more than 10 minutes, OSIRIS-REx begins a 7-year journey, reaching its asteroid target Bennu in 2018. And after a survey of the asteroid to characterize it and locate the most promising site, OSIRIS-REx will collect a sample with its robotic arm and return it to Earth via a detachable capsule that will parachute to Earth in 2023.
Anytime after the terminal count status check, the observer shall announce hold, hold, hold on channel 1, identify their station, and briefly state the reason for the hold.
L-minus 9 minutes, 30 seconds.
NSC LCNet 1.
NSC.
Spacecraft to internal power.
Roger.
NASA Spacecraft Coordinator Brett Perkins asked to transfer OSIRIS-REx to internal power.
Enable position.
SRB ignition enabled.
Verify FCO, RCO, and OSM hold fire switches are in the proceed position.
Ready to proceed.
Redline monitor and event table are in the correct configuration for terminal count.
Roger. Flight control, perform launch on time verification.
Roger.
T-minus 8 minutes, 35 seconds and counting. Everything remains go.
Launch on time verified.
Roger. RC verifies solar radiation acceptable for launch.
Verified.
LC switched to ready position. All steps are complete prior to the status check.
And NASA Spacecraft Coordinator Brent Perkins confirms that the OSIRIS-REx spacecraft is on internal power, key milestone leading toward launch today. We're at T-minus 4 minutes and launch minus 7 minutes, 16 seconds and counting. Number of polls being conducted so far, no issues. Everyone continues to be go.
Status check to proceed with terminal count. Atlas systems, propulsion.
Go.
Hydraulics.
Go.
Pneumatics.
Go.
LO2.
Go.
Water.
Go.
Centaur systems, propulsion.
Go.
Pneumatics.
Go.
LO2.
Go.
LH2.
Go.
ASGAS.
Go.
Electrical systems, airborne.
Go.
Ground.
Go.
Facility.
Go.
RFFTS.
Go.
Flight control.
Go.
COM.
Go.
Timer.
Go.
GC cube.
Go.
Umbilicals.
Go.
ECS.
Go.
Redline monitor.
Go.
Quality.
Go.
Op safety manager.
Go.
ULA safety officer. Vehicle system engineer.
Go.
Anomaly chief.
AC is go.
Range coordinator.
Clear to proceed.
Launch director.
LD is go, and you have permission to launch.
Proceeding with the count. Timer T0 is planned for 23:05 Zulu. Set count to start at 23:01 Zulu.
Roger. T0 is set for 2305 Zulu. Count will start at 2301 Zulu.
Launch polling is complete, and we have a go for launch in 5 minutes, 37 seconds. We're about a minute and 30 seconds away from coming out of our T-minus 4 minute hold.
CNET 1.
NSC.
Verify spacecraft is on internal power.
OSIRIS-REx is on internal power.
All steps are complete prior to terminal count.
And once again, as you heard, OSIRIS-REx is on internal power. Launch minus 5 minutes. 1 minute away from coming out of our hold. From now until launch, you'll be listening to launch conductor Scott Barney and his team performing the final steps in the countdown procedure. You'll hear the team securing Atlas liquid oxygen topping, followed by the call to transfer the Atlas
On my
and Centaur
mark,
stages.
T-minus 4 minutes and counting. 3, 2, 1, Mark.
And we're at T-minus 4 minutes and counting. Atlas and Centaur stages will be transferred from ground facility power to internal battery. At T-minus 1 minute 55 seconds, the team will command the ground launch sequencer to start, followed shortly by securing the Centaur liquid hydrogen and liquid oxygen topping activity. T-minus 3 minutes and counting. A brief look at the Mission Director Center in the Atlas Spacecraft Operations Center.
50 seconds.
FTS internal.
And the Launch Control Center. Flight termination system is on internal. Everything is going by the timeline. Standing by to transfer the Atlas power to internal and the Centaur power to internal in about 25 seconds. Once again, crowds gathered expectantly awaiting today's launch, a little more than 2 minutes away. T-minus 2 minutes and counting.
1 minute 59.
Vehicle internal.
155.
Launch sequencer start.
150.
Securing Centaur LH2.
Securing Centaur LO2.
140.
Launch enabled.
137.
Flight control system is to launch enable.
FTS armed.
In the final minute, the Atlas tanks will be verified at flight pressure, followed with verification of the Centaur tank pressures. 1 minute, 21 seconds and counting.
OCUs armed.
FCS count started.
115. 110.
Set valve block.
T-minus 1 minute and counting.
Status.
Range green.
No issues with the range. Everything continues to be go. A final status check of Atlas, Centaur, and OSIRIS-REx readiness will be conducted 25 seconds away from launch. T-minus 40 seconds.
Stable at step 3.
$28. 25.
Status check.
Go Atlas.
Go Centaur.
Go OSIRIS-REx.
Everyone is go. Standing by for launch. After liftoff, you'll hear the voice of United Launch Alliance's Marty Malinowski providing launch vehicle ascent data. 10 seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1. And liftoff of OSIRIS-REx. Its 7-year mission to boldly go to the asteroid Bennu and back.
Hydraulics look good. Starting pump speeds and injector pressures are within family. Repeat chamber pressures have plateaued, begun to ramp off.
Heard the voice of Marty Malinowski. The Atlas has begun a pitch and yaw maneuver to steer to its planned path, 28.5 degrees inclination from the equator.
SRB chamber pressure is almost plateaued at this point. RD 180 injector pressures look good.
45 seconds into flight.
Roll program is complete. Boosters throttled down.
And the Atlas rocket carrying OSIRIS-REx has gone supersonic. Standing by to pass through max Q, maximum aerodynamic pressure.
Max Q, vehicle body rates continue to look good.
This is the point when the mechanical stress on the rocket reaches its peak
And
because of the
has
rocket's
throttled back up.
velocity and resistance created by the Earth's atmosphere.
Signatures look good. Current altitude is 14 miles. Downrange distance is 9 miles. Current velocity 2,488 miles per hour. Range track shows vehicle progressing down the middle of the range.
In about 30
RD-180
seconds,
continues to look
the
good. Pump
single
speed.
solid rocket booster will be jettisoned at 2 minutes 19 seconds.
And booster has throttled back down. It's now 50% of its liftoff weight. Next major event will be SRB jettison, coming up momentarily. we
And
have
you see the
indication.
solid rocket booster jettison.
Solid. Separation looks good. Vehicle has enabled closed loop Q alpha steering.
RD-180 engine continues powering the Atlas, Centaur, and OSIRIS-REx into space. Next major milestone will be booster engine cutoff. 4 minutes and 2 seconds into flight.
Valve has been fired. That system is now pressurizing to flight level. Signatures look good. Current altitude 40 miles. Downrange distance 75 miles. Current velocity 5,988 miles per hour. Range track looks good.
About 1 minute away from Atlas booster engine cutoff.
Already went to burn well. Pump speeds, injector pressures within band. Vehicle body rates look good. Vehicle is now 1/4 of its liftoff weight. Coming up on our 5G throttle segment momentarily. And we have begun throttling to maintain 5Gs. Signatures look good. Boost phase cooldown is underway. And begun to throttle to 4.6 Gs in preparation for BECO. Boost phase cooldown is complete. And we have BECO. Engine shutdown looks good.
Booster engine cutoff confirmed. Standing by after
And we have
spacecraft separation for the Centaur single RL-10C engine to ignite.
We have ignition and full thrust on the RL-10. Coming up on payload for jettison.
Everything continuing normally. The Centaur engine producing 22,900 pounds of thrust, and it will burn for just over 8 minutes.
Centaur body rates look very good. Steering has been enabled.
And the payload fairing, which was covering OSIRIS-REx, was jettisoned. Everything continuing on the timeline.
Current altitude for Centaur is 101 miles. Range, downrange distance is 471 miles. Current velocity 12,589 miles per hour. We do have a report from the booster performance, and it is basically nominal. Centaur PU is currently on the Oxford stop. Chamber pressures look good. Ox pump discharge, fuel venturi, and pump speeds all are good.
6 minutes into the flight of OSIRIS-REx.
RL-10 continues to perform well. Chamber pressures, box pump discharge, and fuel venturi all within expected range. Centaur PU has come off the LOX ridge stop. Body rates controlling down the middle.
About 6 minutes left in the
Ready.
burn of the Centaur engine.
Battery voltages all are stable at this point. Tank pressures look good. And we have had the format change. Very minor loss of data during that. We're seeing our normal thermal conditioning firings on the RCS. Line temperatures have nearly warmed to bottle temperatures at this point.
Once again, you're hearing the voice of United Launch Alliance Marty Malinowski
Range track.
calling the ascent of the vehicle.
We're still making good progress down the middle of the range. And Centaur has begun RAN steering at this point. Current altitude 139 miles, downrange distance 1,008 miles, current velocity 13,783 miles per hour. And the RL-10 continues to perform well. Chamber pressures, box pump discharge, and venturi all where we would expect for the set MR. Centaur body rate still controlling down the middle.
About 4 minutes remaining in the burn of the Centaur engine. You can see the
Centaur
spacecraft traversing out over the Atlantic Ocean.
Downrange distance 1,275 miles. Current
On a
velocity
28.5 degree inclination from the equator.
Range track again continues to show good progress downrange. Centaur PU has worked off most of the oxidizer air at this point, controlling near nominal. Chamber pressures, box pump discharge, and fuel venturi again all as expected for the set MR. Body rates are good. Centaur continues to perform well. Current altitude 145 miles. Downrange distance 1,597 miles. Current velocity 15,333 miles per hour.
Just a little over 10 minutes since launch, and everything continues to go well.
Approximately 2 minutes remain in this first burn. All Centaur systems look good. Centaur PU, again controlling near nominal. RL-10 performance continues to look excellent. Body rates controlling down the middle. Approximately 1 minute remains in this first burn.
Standing by for the second stage Centaur engine cutoff.
138 miles, downrange distance 2,143 miles, current velocity 16,942 miles per hour.
MECO 1 coming up in about 10 seconds.
Vanish. And we have IAP vanish. Centaur is now orbital. And we have MECO. Engine shutdown looks good.
MECO is confirmed.
We have safety flight termination system. Centaur has gone to 4S settling.
Another Centaur burn will follow after about a 22.5-minute coast period. That burn is scheduled for 33 minutes, 48 seconds mission elapsed time, or about 7:38 p.m. Eastern Time. As the journey continues to
this coast phase is scheduled
put
for
OSIRIS-REx into its planned location in space.
Followed by a second burn of 407 seconds and a final coast to spacecraft separation of 15 minutes. Centaur tank pressures, storage bottles, batteries are all stable.
The Centaur engine will burn once again before finally releasing the OSIRIS-REx spacecraft into space about 55 minutes and 38 seconds after launch.
And looking at the MECO 1 plus 3 second open shows Centaur's right where we expected, and comparing the pre-flight to the actual position of the vehicle. Centaur RCS has begun to ramp to a 25% 4S duty cycle.
Once again, we're in a coast phase between burns of the Centaur engine. We're expecting that the next burn will begin in about 16 minutes. And right now, while we are awaiting the engine restart, we'd like to show you an interview that NASA Communications Representative Josh Finch conducted with NASA Chief Scientist Ellen Stofan.
Thank you. I'm here with Dr. Ellen Stofan, NASA's chief scientist. We're just outside of the Vehicle Assembly Building, and just a few miles away is OSIRIS-REx on the launch pad, ready to head to the asteroid Bennu to collect a sample and then return it back to Earth. Dr. Stofan, what can we learn about studying asteroids that could benefit us in learning about our solar system?
Asteroids are the primitive material left over from when the planets formed. So the Earth, us, this building, everything around us, asteroids are the key to what were those materials that everything that is around us was made. Now everything on the Earth has been processed, all this material has been processed and processed. Asteroids are the pristine material, and we know they contain really interesting things like the water, that is the water that originated our oceans and all the water here on Earth, and they actually also contain organic molecules that help make us.
And so why did NASA pick Bennu as an asteroid to study, and what are the benefits of a sample return mission?
You know, Bennu is what we call a carbonaceous asteroid. Now, carbonaceous asteroids are the ones where we know they have a lot of water in them, and again, we think that water is the source of the water that's here on Earth, and we know they have organic molecules on them. In fact, some of the letters in our DNA that make up our DNA, those molecules have actually been found in carbonaceous meteorites. So Bennu could hold keys not just to the origin of water on Earth, but to the origin of life on Earth. So we're particularly interested in that type of asteroid. Now, when you send a spacecraft to either a planet or an asteroid, you take along instruments and you do the best job you can of characterizing the material. But you have to realize when we shrink a scientific instrument to fit down onto a spacecraft, it becomes a little less capable. If we can actually bring those rocks back here to Earth, we can analyze them with instruments that fill a room, basically. We get much more precise and better information. So scientists, especially geologists like me, we like to get those rocks back here on Earth where we can do really amazing science with them that we just can't do remotely.
And now NASA's planning to do an asteroid redirect mission and then eventually a journey to Mars. How does this mission help that goal?
You know, because small bodies are potentially really interesting in the future for resources, they're really interesting for water, and of course we're concerned about them from a planetary hazard point of view. Asteroids have hit this planet in the past, and they will hit us again at some point in the future. The asteroid redirect mission tests technologies like solar electric propulsion that we're going to use to get cargo out to astronauts who will someday be out at Mars. We're also going to be testing techniques that will help us understand how we might in the future potentially deflect a hazardous asteroid. So it's helping us protect this planet, and the asteroid redirect mission is going to help us to get us on our way to getting humans to Mars. And OSIRIS-REx is really the first step. It's teaching us how do we get to a small body, how do we maneuver around it, how do we get a sample back. It's the first step. The asteroid redirect mission is the next step.
Excellent. Well, thank you for being with us today. And back to you.
Thank you, Josh. Everything continues to go well. Once again, looking at animated graphics driven by real-time telemetry showing the position and status of the Centaur spacecraft with the OSIRIS-REx payload. The next burn of the Centaur engine scheduled for 33 minutes and 48 seconds after launch. So about 12 minutes from now. Once again, everything continues to go well. Heading toward an on-time deploy of the OSIRIS-REx spacecraft about 55 minutes and 38 seconds following launch. This is Atlas Launch Control.